PhD student in civil engineering from the Hong Kong University of Science and Technology. And my supervisor is Professor Yantao. It's my pleasure today to share my research topic about the two-stage task scheduling methods for HRC construction tasks. So the construction industry faces several challenges. The first one is the high physical demands. As we all know, the workers need to work in a fast-paced environment for a long period without sufficient rest. So from the figure, we can see that the construction workers have the highest rate of suffering from the musculoskeletal disorders. Also, there's a lack of interest in the younger generation in construction because maybe due to the heavy work. So there's a lack of the human manpower resources among the construction workers. And also, the construction industry is globally recognized as having the least integration of the automated and digitalized technologies. So in the past few years, there has been a decline in the productivity across the entire industry. And that's because the traditional construction pattern has reached its limit of the technological performance. Therefore, the construction robots are needed in the construction sector, considering their ability to improve the productivity while relieving the workers from the dangers and also the heavy work. However, the on-site autonomous robots haven't been widely adopted because the construction sites are dynamic and unstructured, so that may contain many unexpected and uncertain situations which limits the ability of the autonomous robots. It requires the robot to accurately perceive the unknown environment and also react to it. So the autonomous robots that rely on the pre-programming face a big challenge. Most construction robots are not advanced enough to perform the task independently. So there's a lack of interest, there's a lack of the high quality training data sets we can see here for autonomous robots to train and deploy in the construction site. In order to face the complex and changeable construction sites, so we require some characteristics like the intelligence, the dexterity, and also the adaptability, which actually owned by the human workers. So the HRC team is actually the human-robot collaboration becomes a promising solution that can combine the strengths of both human workers and also the robots. And for the HRC, the primary goal of the HRC is actually to improve the overall performance. The evaluation criteria typically includes like the well-being, the productivity, as well as the cost. So the task scheduling plays a crucial role in HRC, where it defines when and who will perform the specific task. That's the basic definition of the task scheduling. And a well-designed task schedule can help deal with the task dependencies and also streamline the overall workflow. It can also identify the potential bottlenecks. Like here we can see that's streamlined, and also maybe there's some idle time that's the potential bottleneck, and also it will consider the availability and also the allocation of the whole resources and try to maximize the utilization of these resources. So to ensure the effective collaboration within the hybrid team, we need to advance the system task scheduling. And we will review the work rest scheduling and task sequencing as the two main branches of the task scheduling method. And for the work rest scheduling, there are also two categories. The first one is the simulation-based methods. So in this one, we will usually using the discrete event simulation or the agent-based simulation. For this example, it uses the discrete event simulation, but it also tries to investigate the impact of various work rest schedules on the performance. For example, in this situation, they just try to compare the work rest schedule with or without the voluntary work rest. And the second category is using the mathematical methods like the linear programming for this one to find the optimal work rest schedule. But it will constrain the numbers and also durations of the rest. For example, in this case, it will try to allocate or arrange 3 rests with the duration of 5 minutes in this schedule. And so this may overlook the benefits of the more flexible and also shorter rest periods, but the finer time granularity will result in the expanded search space. So it may not be responsible for the linear programming. And for this one, and also for this task sequencing in construction, current research primarily addresses the overall project. For example, this one, it solves like a 40-day project for the whole construction project, but it's not so dedicated for the flexible and also the task scheduling actually in the human-robot collaboration. And so to conclude, there are 2 gaps in current HRC construction. The first one will be the work rest scheduling and the task sequencing optimization have been treated as 2 independent problems. And the challenge will be, so the unstructured construction task will strengthen the interdependencies between the work scheduling and also the task sequencing. So in specific, the sequence of the task will have an impact on the timing and also the duration of the required rest periods. Simply said, we can say when the worker undertakes some physically intensive activities, they need the longer recovery times to elevate the fatigue and also maintain the productivity. So our question is, how can the work rest scheduling and task sequencing be integrated into a unified optimization framework to address their interdependencies in the unstructured construction environments? And for the second gap is the discussion on the scheduling issues centered on the manual work environment in guiding the HRC scenarios. And the challenge here is the unique features of human, like the dynamic productivity, as we all know, and also the robots. They can continue work, so how to utilize this high physical performance in the task scheduling of HRC. And our question is how to incorporate the unique characteristics, the features into the task scheduling framework to optimize the performance. And for the framework here, so we propose 2 methods. The first, it's also the 2-stage method. So we will try to firstly optimize the work rest schedule first, and then we will replace this broad work here, the broad work type, into some specific task here. So this 2 steps. The first step is to optimize the work rest schedule, and the second step is to optimize the task sequencing. And for the second method for this one is firstly fix the task sequencing, and then we will insert the rest here in some appropriate positions to relieve the workers from the fatigue. And for the problem statement according to the time limit, so I will just quickly here. So for quickly introduce here, considering the high cost of the construction workers, the construction robots, so we will utilize the mathematical modeling to simulate this HRC process. So this approach will simplify the system and also allow us to easily adjust some model parameter. For example, here for the construction task, we will just use the time frame and also some specific task characters to represent the construction task. And for the agents, we characterized by the 3 attributes here, and I will skip this one. And for the methodology, as we said before, the HRC in construction haven't been discussed so widely, so we can get some insights from the line balancing problem, especially in the industry. So we can see the materialistic algorithms as an effective solution, and the GA, which can solve the optimization problems based on the natural selection, and it can handle some nonlinear relationships and also some complex constraints. So for the GA, this is the GA diagram. That's also an example for the 2-stage method 1. So this one in your left part, it will try to find the optimal work rest schedule, as we said before, and this for the right part, based on the best solution of the stage 1, we will try to optimize the task sequencing. And there's also some say the notations for this one. Like this one means the work, we will try to find, okay, work, rest, work, rest, something like that, and then we will find the optimal one. And for this one, we will replace the work into some specific task here, represented by the lower h. Yeah. And another diagram is for the two-stage method 2. So similarly, we will try to firstly find the there's a problem in this feature. Okay, anyway, we will try to find the optimal. Okay, so that's wrong in this feature. Anyway, we will try to firstly find the optimal task sequencing almost similarly. So this will be the first part, and this will be the second part to find the optimal task sequencing. And for the case study, we will utilize the SAM 100, the bricklaying robots, because the bricklaying is one of the most traditional building method, and we can see even if the robot can do the bricklaying, we still need human to supplement the brick and also the mortar, and also we need them to remove the extra mortar, and there's some parameters. Anyway, I'll skip that. And according to the results, we can see this is the objective and also the normalized results of the two-stage method 1 and the method 2. For this one, we can see for the two-stage method 2, which we firstly optimize the task sequencing, it performed better on the work output and also the robot utilization. So this one is higher, better. So we can see it has the higher output and also with the stable performance. That's maybe because when we firstly optimize the task sequences, so the variation is really stable and really small. But for the two-stage method 1, we firstly optimize the progress schedule. It has a higher variation, but it really performed better on the accumulated fatigue. So this one is lower the better. So we can see the two-stage method 1 has a lower accumulated fatigue. So that's actually a problem whether we will prioritize the human-centric wellness for method 1 or the task-centric efficiency for the task method 2 as the foundational task scheduling principle. And that may result in some possibility in the future for the call optimization. We can see the trade-off between the human-centric or the task-centric. Yeah. And also, besides that, in the future work, we'll try to conduct the experiments in the construction sites and also explore the scenario of the multi-robot and multi-humans teams. And that's some reference, and thank you for listening, and that's our lab, just a simple introduction for this one. We will do 3 aspects for the construction robotics and also occupational safety and also the beam reconstruction. You're welcome to scan the QR code to find more in our research. Yeah.